Forgot to include this in the video about quadrilaterals, but here I have a rectangle made out of toothpicks. We would know how to find the area of this, right? We would take the length of the rectangle and times it by the height. There's a principle of mathematics called the Cavalieri's principle, and we'll talk about this later after our project when we start talking about 3D shapes as well. Cavalieri's principle says if two objects have the same base and height, they will have the same area. All right, in 3D, it'll be about volume, but here it's about area. So here, right, base of the rectangle is the length, the height of the rectangle is the width. If I turn this into a parallelogram by making the toothpicks slanted, right, the area does not change, and we can see that because the number of toothpicks, even though they're trying to not be parallel, if they stay parallel, the number of toothpicks stays the same. I'm not adding or subtracting any toothpicks, right? So the base of this parallelogram is still the toothpick width, and then it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's just say 20 toothpicks. It's 20 toothpicks high. So the height doesn't change. So the area does not, right? So that's why I try to use all those same numbers in my examples, because we got all the same area from those different shapes because our base and the height stayed the same. Again, Cavalieri's principle says if it has the same base and height, right? Toothpick, 20 toothpicks, rectangle, it will have the same area as a parallelogram, even though we change the angles involved, because there's still 20 toothpicks, because the height stays the same, because it's still one toothpick wide, because the width stayed the same, we'll have the same area. That is Cavalieri's principle with toothpicks for quadrilaterals. Same thing would work with triangles if we just had a triangle. It's not nicely done. If we had a triangle made out of toothpicks, which would be very hard to move around, but we can see this as the diagonal, right? That triangle, which right now is not right, if we made it into a right triangle, it would still be a half of the rectangle, and then again, half of the parallelogram. So that's why it doesn't matter what type of triangle we have, as long as we know the base and the height, it'll just be a half times the base height, right? So Cavalieri's principle.